Chapter 9 is about right triangle trigonometry. Trigonometry is literally the study of right triangles. So what we're going to take a look at is we're going to notice that if you have a right triangle and you have one angle, well, you get the other angle by free because of 180 degrees is the sum of it. But what's also nice is if you have a 90-degree angle and another angle, you now have similar triangle because angle, angle refers to angle, angle. So that means all right triangles with one measure are similar. So that means if two things are similar, their sides are in proportion or ratio. And that's what Trig's about, is saying that these sides are in proportion or in ratio. We have three trig ratios we use: the sine, the cosine, and the tangent. Sine being that one, sine, cosine, and tangent. Most of you remember SOHCAHTOA. Sine is the opposite over the hypotenuse, the adjacent over hypotenuse is the cosine, and the tangent is the opposite over adjacent. So the big thing whenever we look at this is we have our trig function and an argument. Inside of it is always an angle. A represents the angle we're looking with respect to, so right here. So if you look at angle A, which is right here, we're going to look at the opposite side, which in this case is little a. And then the hypotenuse is C. Similarly, cosine, we look at the same angle, but now we look at the adjacent. That's the adjacent, which is letter B. And then we look at the hypotenuse, which is C. All right. Tangent is the opposite of it, or across from it, which is A, and the adjacent is B. One of the most important realizations is, if we change to angle B, these ratios will flip. Notice how sine becomes the opposite over the hypotenuse, B over C. It actually becomes the cosine of A. We'll never, ever, ever use the right angle with respect to. Those are specialty, so understand it. Also, remember the hypotenuse is never, never, never going to be the opposite side. So we continue onward. We should be able to figure out some basics out of this. Now, if we look at sine of A, sine we know is opposite over hypotenuse. We pick angle A, the opposite is 4, the hypotenuse is 5. Cosine is adjacent over hypotenuse. The adjacent of A is 3, the hypotenuse is still 5. Tangent is the opposite over the adjacent, which happens to be the opposite, which is going to be across from A, which is 4, and the adjacent is 3. Similarly, we're going to see that sine will definitely be a little different for B, but it's still the same ratio, opposite over hypotenuse. But now with B, opposite is 3, the hypotenuse is 5. Adjacent over hypotenuse, the adjacent is 4, the hypotenuse is 5. Notice how 5 is always the hypotenuse. And the tangent, opposite over adjacent, is going to just be opposite, which is 3, the adjacent is 4. Notice there is a relationship between these two, and these two, and these two. And yes, that's always going to happen. Alright, so if we take a look at this problem here, this is a right angle. Sorry, I didn't write that in there. You should be able to find PR, which is across. Being a right angle, we should know that we should be able to use the Pythagorean theorem. C squared equals A squared plus B squared. C squared equals 12 squared plus 5 squared. 144 plus 25 equals C squared. C squared equals 169, so C, take the square root of both sides, and you get C to equal 13. This is a 5, 12, 13 right triangle. From here, we should be able to figure out the sine of P. P is right there. Sine is opposite over hypotenuse. Opposite of P is 12. The hypotenuse is always going to be 13. Cosine is adjacent over hypotenuse. Adjacent is next to, that's not the hypotenuse, which is 5. 5 over 13. And then tangent is opposite over adjacent, which is just the opposite, which is 12. The adjacent is 5. Okay. If we take a look at the cosine, or the sine of r, we are now respecting this angle over here. So we're using this angle as it. Opposite over hypotenuse. Opposite is 5. Hypotenuse is still 13. That hasn't changed. Cosine is adjacent over hypotenuse. The adjacent, in this case, is 12. The hypotenuse is still 13. And then the tangent is opposite over adjacent, which is, the opposite is going to be 5, and the adjacent is 12. Notice how I'm not using all of that 13 there. Alright, so you can see this is our basic trig, and we should probably remember this from, days gone by. So, what leads to is, we're going to get into a specialty triangle. So what's really cool about this is, think about this. We have a standard equilateral. That means every angle is 60 and 60. Then these two have to be, I'm 30. Remember, if you draw an altitude, it bisects it. So these are also going to be the same. So if this is 6, this has to be 3 and 3. So making AD 3. This is 6 because it's equilateral. So AD is this height of the triangle. Well, we know that we can figure this out by doing, again, forming a right triangle. We have c squared equals a squared plus b squared. So this time we know the hypotenuse is 6. The adjacent is 3 squared and b squared. 36 equals 9er plus b squared. Subtract 9. We've got this to be 36 minus 9, which is going to be 27, equals b squared. You take the square root of it, and you get b to equal, the square root of 27 is 9 and 3, so that's 3 radical 3. 3 radical 3. We already determined DBC to be 30 degrees. So, I want the sine of 30. That means all I got to do is take a look at a 30-degree angle. I'll look at that one. And then all I need to do is look at the opposite over hypotenuse with respect to that. So the opposite is 3. The hypotenuse is 6, which is going to be 1/2. Now what's cool is this is true out of all 30-degree angles. It has to be. All of these triangles are proportional to one another. So whenever you make a triangle like this, you're always going to have a ratio of 1 to 2. The sine of 60, on the other hand, so the sine of 60, change it up a little, 3, is still opposite over hypotenuse, but now we're looking at this angle. So the opposite is the one across, is, well, BD, which is what we found here, is 3 radical 3 all over the sine of 60. Hypotenuse, which is 6. So 3 radical 3 over 6 is radical 3 over 2. Alright? And again, that's always true. Sine of 60 is always that. If we look at cosine, adjacent over hypotenuse, the adjacent of the 30-degree angle is going to be this one right here, which we found to be 3 over radical 3. The hypotenuse was 6. What do you know? Radical 3 over 2. So the cosine of 30 and the sine of 60 are actually the same. The cosine of 60 is adjacent over hypotenuse. Well, the adjacent here of the 60-degree angle is 3 and our hypotenuse is 6. Well, again, 1/2. Sorry about the little dots. Apparently it doesn't like my hand. All right. Lastly, we have tangent. Tangent is opposite over hypotenuse. Well, the opposite of 30, so I'm going right here, the opposite of 30 is 3. The hypotenuse, oh, sorry, tangent is not opposite over hypotenuse, opposite over adjacent. The adjacent is, I'm on 30, right? Tangent 30. Opposite is 3. The adjacent is what we found, which is 3 radical 3. 1 over radical 3. If we rationalize this, we get radical 3, which is radical 3 over 3. And then the last one, for tangent of 60, again, opposite over adjacent. Now we're at the 60. The opposite is what we found, which is that 3 radical 3. And the adjacent, which is 3. Well, now that's radical 3, because those cancel out. And these are all specialty angles we're going to see throughout this class. All right? So, you can see this is a little bit of a review of right triangle trig you should remember from your first years of algebra. But hey, a refresher isn't going to hurt you. You take care, and I'll see you in class.